Or from a calculus point of view, given this, we take the derivative, use the chain rule, so the derivative of omega t is omega, so that gets popped out front, and so forth. So now I take an ideal spring. I attach a mass to it. I stretch the mass. In other words, I pull the mass down and I let go, and the thing will oscillate back and forth. Just a very quick example, this is what I'm talking about. I have this right here, I add a mass to it. So before turn up to the smaller mass.
Yeah, they're down on the shelf.
Pardon?
I was just gonna say they're down on the shelf over there.
Yeah.
We used those last time.
Yeah, there used to be some floating around up here, that's what I was looking for at first. All
You
right,
mean, oh wait, no, this isn't small, that's.
this will work. So I put the mass to it, it now hangs down farther, and then I pull down and I let go. And if you look at the motion of that, now it's not ideal, but we're gonna pretend it is. And actually, when you do the math for it, it comes out relatively nice. Now, what's driving this, if it's ideal especially, is Hooke's law. In other words, the force that the spring exerts is equal to the negative, try that again, is equal to negative k delta x, which is equal to mass times acceleration. So this is Hooke's law, and then Newton's law should also be valid. So we have this force is equal to mass times acceleration. Which means that if something obeys Hooke's law, this must be true. And so I want something where, well, that is the second derivative, that is the slope of position. I need some function of x that where when I get to its slope, I get basically the same thing other than some constant out front. Well, lo and behold, and I want it negative. Lo and behold, if I start with a cosine function, I end up with a negative cosine function. If something obeys Hooke's law, this equation satisfies the equation. This is a solution for that. So we have negative k times a cosine omega t plus phi. So that is. Now I do want to point out I am sort of equating position and displacement here. In order to do that, I need to establish that my position is 0 at equilibrium. And that's equal to mass times, and I didn't give myself enough room, so I'm going to rewrite this. You know what? So I have negative k times a cosine omega t plus phi equals mass times a negative a cosine omega t plus phi. So this is my displacement from equilibrium, but I'm setting equilibrium equal, my origin to be where equilibrium is, where there's equilibrium. So that's my delta x. That's my acceleration. If I'd done sine, the same thing would have worked. And now let's cancel out the common things. My amplitude cancels out. The trig function cancels out. Oh, mistake. Try that again.
It's an acceleration. Is that,
Pardon?
what was it, acceleration you were missing? So,
Yeah, I left off the omega squared.
okay.
Negative omega squared a cosine omega t plus phi. All right, now let's get rid of stuff. All right, so a cancels out, the trig function cancels out, the negative sign goes away. So, since this satisfies Hooke's law for motion and Newton's second law, we end up with the fact that the spring constant, K, is equal to the mass times omega squared. So omega squared is the spring constant divided by the mass, or omega is the square root of K over M. So for something in that is obeying Hooke's law, the angular frequency is just the square root of the spring constant divided by the mass. Take it one step further. The period. This is period, capital T, period. In other words, how long it takes for it to do one complete cycle. If we think back to our equation right here, when omega was 3, my period was 2 pi over 3. Matter of fact, it's going to be 2 pi over omega. My period is 2 pi divided by my angular frequency. So this makes the period 2 pi times the square root of m over k. Just 2 pi divided by omega is the same as 2 pi times the reciprocal of omega. That's why that was. Frequency.
One over the top.
1 over the period becomes 1 over 2 pi times the square root of k over m. Now the symbol for frequency that I use is what I call a Baroque F. There is another symbol for frequency that is often used, and it's unfortunate.
Hertz.
That would be the units.
Oh.
But the other symbol for frequency sometimes is the nu. The Greek letter nu.
That we used.
For Poisson's,
Yes,
Poisson's, what was it, ratio?
Poisson's ratio.
Oh, Poisson, right?
Now the trouble with nu as the frequency, we'll demonstrate right here. What is speed?
Change in position over time.
Scalar, so yeah, distance over time.
Okay.
So if I am producing a wave in let's say I've got a long coil and I'm going up and down like this, or think battle ropes, if any of you have seen those in the gyms, the big ropes. You're sending waves down. The time it takes you to produce a wave is the period. That's to go up, down, and then back to where you started in the same direction. So that would be the period. What is the distance that the wave travels in the time it takes you to do that?
Length of the rope?
The wavelength.
Going for wavelength, not necessarily the length of the rope. It could be, depends on how fast you're doing it.
Yeah.
Length.
So this is a lambda. It represents wavelength. So the speed of the wave is just the wavelength divided by the period. That's for producing constant waves. Which is the wavelength times 1 over the period, which is the wavelength times the frequency. Frequency and wavelength are opposites, are reciprocals of each other. You can think about it this way. The period is the time per cycle, and the frequency is the number of cycles per time.
That's actually a good way of describing them. Never thought about, yeah, it shows a relationship between them as well.
So we have a relationship here between wavelength, frequency, and speed. Now, if you use a nu to represent frequency, this equation looks like this.
Oh, man.
Now the trick is, or just the knife in the gut, whatever it is, some fonts will do the exact same equation, except a different font will make it look like this.
Yeah, that font would probably be me.
So when I run into the situation where I've got a nu for frequency, I have to find this equation to figure out which one is their V and which one is their nu. Now, I'm not planning to use nu for frequency. I bring this up because if you're looking at another source and suddenly you see something like this, I had, my first year here, there was a student doing nanotech, and she asked me a question. She came by and wanted to know if she could ask me a question. I said, yes. She said, why is there a V in this equation right here? Right here. I said, oh, yeah, that's not a V, that's a nu. So if you run into it, somewhere in the back of your mind, you're going, wait a second, I've heard something about this.
Well, no, the wavelength is always 1.
It's a new math.
Yeah. I get it, new.
Yeah.
There's another equation, there's capital V used for electric potential and also the unit of volt. And electric potential units are volts. So you can have an equation of V is equal to 5V, which in physics means the electric potential is 5 volts, but in math it means V is 0. Another difference between us. Still time. All right, so what we've established is that if Hooke's law is obeyed, and generally the code word is, if someone talk about it, well, sometimes they just explicitly say Hooke's law is obeyed, but ideal spring, ideal elastic material, Hooke's law is obeyed. Then the angular frequency of the motion is the square root of the spring constant over the mass that's being moved by the elastic material. The frequency is 1 over 2 pi times the square root of k over m. And the period is 2 pi times the square root of m over k. We can do one other relationship here. We can do lots more, but one other relationship sort of pops out. If I look at these two equations here, notice this square root of k over m, that's just omega. So my frequency is equal to 1 over 2 pi times omega, or omega, my angular frequency is equal to 2 pi times my frequency, sometimes called linear frequency, but if someone just says frequency, they're talking about f. Questions to hear? All right, let's take a look at units. This, by the way, I did this yesterday also, or Monday. I've done it at some point this week. The symbol for units,
Seconds.
yeah, it is
Yes.
seconds. I'll put SI if I'm specifically looking for SI units, and so that would be seconds. Some textbooks, instead of doing the square brackets like that, they will do sort of they'll do square brackets, except they'll put an extra bar in there to symbolize units of. The SI units of frequency, which is 1 over seconds, which is in exponential notation, that's -1. The units of angular frequency, SI units.
Hertz?
It is not.
Is it radians per second? Radians per second?
It is. Because there's a radian sort of associated with this. This frequency has units of seconds. This is technically 2 pi radians. And so this is radians per second. What's a radian?
About 53 degrees.
How'd they get that?
It's the ratio of pi to the circumference. Or no, not the circumference, to, let's see, pi over 180,
It'd be 2 pi over 360.
or 365.
Or 360 over 2 pi, if that's where you're going.
Pi over
But
180, or
Is-
is it 180
But-
divided by pi?
why 2 pi?
I don't remember, it's like the radius of the circle extrapolated to the circumference, to like the circle itself. The arc length of that is 1 radian.
Yeah, you're pretty much you're pretty darn close. The words might be slightly
Well,
off.
I can see it in my head, I just don't know how to describe
Right.
it.
So if I have a circle, especially in the 18th century, no, 19th century, French mathematicians, at least with the histories that I've heard of math, they generally blame the French, credit the French. They were trying to get math down into removing as much mankind interpretation as possible. I mean, the symbols obviously are man-made, but 360 degrees is man-made. So you really want to get it down to, is there something natural, a natural unit that we can use here? So where does 360 come from anyway? 360 degrees in a circle. What'd you say?
No, so I have no idea.
All right. The Babylonians, actually.
Oh.
Babylonians, 60 was a really important number to them. And mathematically, it actually is a pretty neat number. 60 is divisible by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. A lot of numbers go into 60. So Babylonian mathematicians figured out there's something special about this, but they had 60 as a really important number. And I think they tied some religious significance to it. The triangle, the equilateral triangle, also is a really important shape. It's one of those perfect shapes. And so they made each of these angles here 60. Thus 180 degrees in a triangle, the Babylonians. They also noticed that if I take 6 of these equilateral triangles, I actually form a full circle. And so if each of these is 60 units, that puts 360 in a circle. But the mathematicians, more modern mathematicians, looking at this and going, that's man-made. Let's see if we can come up with something that is a little bit more universal. And so they noticed, I have a radius, all circles have a radius. If I take that radius and I wrap it around the side here, there's an angle here that is subtended. So if the arc length here is the same as the radius, and so that is 1 radian. And so how many radiuses can I fit around the outside of a circle?
Pi. 2 pi.
Yep, 2 pi radiuses is the circumference. And so that's why there's 2 pi radians. All right, that is telling me that we should talk about the lab. So quick shift in gear. And this will keep going off unless I stop it.
What time is it now?
It's 11.
Okay.
Okay, a couple of bookkeeping things on lab. Any questions before I talk about lab? All right, the lab is due 1 week from today. I will talk about how nitpicky I am in what you hand in to me. Some labs will have a group of 5, and some labs we'll break it up into a group of 2 and a group of 3, or whatever we happen to have. I'm inclined to go 1 group of 5 today. However, if you're not comfortable with that, we can split it up. You will have face shields. You'll be wearing masks and face shields. If you need to take the face shields off, I have face shields in the other room. Or if you have one, great. If you need to take the face shield off because it's fogging up, step away from everybody, take it off. Student last semester had a COVID scare, and he spent a lot of time. He and his lab group were usually in another room, and oftentimes I'd walk in there and they didn't have the face shields on. Fortunately, he ended up being testing negative, so crisis avoided there. All right, group name. If you'll notice at the top, you'll have your name, which obviously put down your name. Put down the name you want to be called. The group name needs to agree. Spelling for spelling, punctuation for punctuation, strange symbol for strange symbol. You don't have to use the same font, but uppercase, lowercase need to be the same. A couple years ago, I had a group that spelled group that way, and that's fine, there's nothing wrong with that, it doesn't have to be a real word. And then someone else spelled it this way, and I thought, oh man, I can't believe that they didn't check to make sure they spelled it the same way. And then as I kept looking, I realized there was actually 3 people who did that one and 3 people did that one. They were actually separate groups. One of the groups sat here and the other group sat right behind them. The issue, I have run into issues where there was a group of 4 over here, and one person was setting up for the next part of the lab. It didn't require 2 people. She was, I think, taping meter sticks to the wall. And this was about halfway into the lab, at which point one of the other people was sitting right here and said, oh, I got a great name for the group. And he said it, the other 2, she was doing her work over here, the other 2 agreed. And so they each changed the name of the group and forgot to tell her. So she ended up getting penalized because they did not include her. So just please be aware, if you change the group name after you started, please make sure that everybody in your group knows. And by the way, they did not do this one, but this is a different name from that, because that's a lowercase g. That is a different name.
Such annoying, right?
Mainly, this is just the habit, especially when you break up. I'm not hovering over you, and by the time I get around to grading it, I'm not going to remember who's in what group usually. So that's why the group name helps me know which people are with which without my having to go through and compare data. There was another group sitting over here, probably collectively the worst handwriting of any group I've ever had. And as I'm looking at their data, I know they're in the same group because they have all the same group name. And by that, it's late enough in the semester, and I think they've been together all semester long. Not required, you don't have to be with the same people every time. And I was looking at their data, there was, I think, 10 different differences in the data. Stuff that was measured directly from the lab, 10 differences in that group. I began to go, were they really the same group? And I checked back, and yeah, the names are the same. Yeah, I seem to recall that they were sitting together. Maybe it's bad handwriting. Now, some issues with, and speaking of data, the data needs to be the same. Everybody in the group in the same group have to have the same raw data. This is stuff that's measured directly from the lab. There's no calculations involved. It is just straight up, hey, what was that number? 5. Okay, write down a 5. Here's the issues that have come up. Trying to learn names here. And I can't read my handwriting. Okay, Holden.
Yes.
Okay.
That's me.
And Gong.
Call, yes.
Richard.
Alex.
Pardon?
Alex.
Oh, thank you. I had a note here that I ignored. Alex, thank you. And then Aaron Thomas. Okay. So Aaron's doing the lab. He's doing the measurement, and he calls it out, and Thomas writes it down. I think I said 2 different names just then. And so what's written down is a 9.
Allegedly.
Now, later on, the person who called out the number is going to copy the information down, that direct measurement. There's no cheating there because it's common data. He looks at that and he goes,
Oh, that's a 4.
what is that? And so he writes down 4. And then someone else copies from one person, the other person copies from the other person, because they were all doing some parts of the lab. And so now I'm left with 9, 4, 4, and something. What I do is I then look at the other person, I look at the papers and I go, all right, does this person have a 9 or a 4 written down anywhere else where I know it's a 9 or a 4, so I can just compare handwriting? If I still cannot decide, I will find whoever happens to be near me at that point and I go, what is this number? And that's the tiebreaker. It happens occasionally, but usually I can figure it out. So let's say the person figures out that's a 9, so I have 2 9s and 2 4s. Well, there's 5 of you, so in this first group, you should be okay. But if there's only 4 of you that day in one group, everybody's going to take a penalty because the majority does not agree. I have had groups before they leave make sure that they all have the same data, and they just read it out and they all check to make sure. If I decide it's 3 4s and a 9, the person who wrote the 9 will I'll circle it sometimes, and I'll just circle it and I'll write MD, which means majority disagrees. Or if it's 2 9s and a 4, I'll circle each of them and I'll sometimes write MDA for majority doesn't agree, which in my mind is a slight difference, but ultimately it's still point penalty. If I say I want you to do a measurement to the nearest to plus or minus 0.001 meters, that means that I'm expecting you to go 3 decimal places when you're in meters. So if it's 4 meters exactly, then I expect you to write in the zeros. They are not the same thing. This has a much higher precision measurement than that is. If you're using the LabQuest, and I'd say to go to 4 decimal places, and LabQuest gives you 4.23 and doesn't give you anything else, you put in the zeros, because LabQuest, after having done this enough, LabQuest is not going to put the trailing zeros. I don't care about significant figures, but I do care about how you record this. When you get to results, rounding could take place. I will grade you on the results, any calculations you make, out to however far you take it. If you round off too liberally, so we're dealing with things at the centimeter level, and you round that off to 4, yeah, I'm probably going to penalize you for that. But if you write this out to, if you're doing a calculation and you write it out 10 decimal places, because that's what your calculator does, I need to be able to match those 10 decimal places. If I can't get the same value you have, and I do try very hard to, if you have it out to 10 decimal places, I try very hard to make sure I get the exact same number you have. There was one case where I took off because I could not reproduce it, and after I handed it back, the student came over and just showed me exactly what she did, and I don't know why I wasn't able to reproduce it, but she got the point back. Questions to hear? All right, repeating units. If you have a table as in the lab, a grid on the paper. And I have length, meters, and you're supposed to record the length here. What I expect, and let's say the instructions say plus or minus 0.01 meters, so you write down 4.21, 3.21, 7.89. I'm not quite sure what you're measuring to get that wide a variety, but this would be properly displayed. Do not repeat the units. It is assumed anything in parentheses here is automatically after this. So if you write meters here, this is 4.21 meters, or meters squared. So do not repeat the units. To nip this one in the bud, I once had a student, but in chemistry, the person can just stop right there. I don't care. Where it really makes a huge difference, where I think probably the best example is that if I have a graph here, and that this is length times 100 meters, then if that's 1, 2, this represents 2 times 100 meters. So this would represent 200 meters. If instead the person had written, if this had been length, that should be capitalized, times 100 meters, then that 2 represents 2 meters. It's the length times 100, which is 2 meters. So this would represent 0.02 meters. The difference about something in parentheses or outside parentheses. Or if they dropped it completely, and this is length times 100 meters. So that means that the length times 100 meters is 2. And so this would represent 0.02 over meters. So how you display it matters. Right, questions to hear? One thing that you'll be doing a lot in labs is making graphs. There should be, and if not, let me know, there should be a way of how to make graphs using Excel. I can't remember which version of Excel. I know that Excel has changed. Sometimes they feel like they just change it because they feel like changing it, not for any particular legitimate reason. If you're using Excel online, please don't. Inherently, it's not evil like Microsoft, but it is, there's some function